And also durability. Once a transaction has ended successfully, it will persist and not be undone. And this is the case even if the system fails, like a hard drive fails and breakdowns, because all the transactions are actually logged, and you can log them to another system, another machine somewhere else.
Okay. So this is in a way, if we go into some theoretical discussion here, it's so that the relational databases, they are founded on some mathematical rules called relational algebra. Mm-hmm. And these are strictly rules of what you are allowed to do. So if you are following these rules, you can always guarantee that you will be consistent. So there are a firm theoretical background to these database systems. Mm-hmm. But we will not discuss this theoretical background really here. It's out of the scope of this course.
Yeah. And we'll look at 3 different problems that might occur in a multi-user database system. And also a sort of reason why you should sometimes have to use transactions. First, we have the lost update.
So there are 2 different persons that are working at the same time to the same database.
We have the transaction A and the transaction B, and sort of a timeline.
So that, okay, there are 2 users, one for transaction A and one for transaction B.
Exactly. And the timeline here is very, very short. It's a fraction of a second. But if you have a lot of users using the same database, sooner or later they will do something at the exactly same time, down to the split second. Okay, here at time 1 we have person A who just makes a request, fetches some data. And a little bit later, person B does the same thing. So now A and B has the same data at their end. But then person A makes an update to this information. And just shortly after, person B also does another update. The problem is that person A has sent back the update to the database, but person B uses an old state of data that's not valid anymore when he makes the update. So that's why the person A's update will be lost, because person B did it after, so this is the state that will be saved.
So if I'm unlucky and I go to the bank and set in a lot of money on my bank account, and some other company might do transactions to my account at the same time, all the money that I put into the bank might get lost.
Exactly. And that's no fun.
No. So
that's one example. Here's another concurrency problem, which is called the dirty read or the uncommitted dependency. Here again we have 2 persons, A and B. First, the person B makes an update on some record. And then just a bit later, the person A makes a request for some data. But person B made a mistake or something went wrong with his transaction, so he makes a rollback. That is, he takes back everything that he did.
Okay.
And goes back to the state before the update. But now we have the situation that person A has information that is taken back, it doesn't exist in the database anymore. And this is called the uncommitted dependency. And finally, the inconsistent analysis. Let's say we have 2 accounts here. Account 1, which has 20 euros, and account B, which has 50 euros. First, person A makes a request. He wants to know how much money do I have in my account. Well, the sum is 20, he finds out. Then the person B makes an update to the account 1. He changes from 20 to 70. Then he sends it back to the database. Just shortly after, person A makes a request for account 2. And he wants to add the numbers of these two accounts. Person A thinks that account 1 is equal to 20 because he doesn't see the update that person B did. So he makes a sum and gets the conclusion that it's 70, which is totally wrong. As you can see, the real sum should be 70 plus 50, which is 120. And this is a version of the inconsistent analysis. It's similar to the other concurrency problems that we talked about.
In the examples we are given here, we have mainly been talking about like accounts and things that happen in split seconds. But these type of problems are perhaps even more relevant when you are talking about the GIS, in a way that if you are doing a transaction in a GIS system, you are not working only in split seconds. You actually have to do something that is called a long transaction. For example, if you are updating a geographic database, you might change the geometry of roads and add new buildings and so forth. And what you're doing then is that you add new objects and you